friends, welcome to our channel. So we know that we were discussing about four principles on which the design patterns has been built. So we have already discussed the first principle, which is program to an interface, not an implementation. Now in this session, let's discuss the second principle, which is favor object composition over inheritance, which means, like in short, we can say prefer composition over the inheritance. Now let's understand this concept with an example. Let's see this. We have a class called parent here. It has some properties like walking, eating, and speaking. Definitely, a parent must be a human being. A human being will be having thousands of different properties. But for the sake of simplicity, we are considering the three simple properties like walk, eat, and speak. And it has its implementation as well. So now let's consider the child as which is inheriting the parent here. So and it has its own implementation of walk, eat, and speak. That means we know that whenever a child is inheriting any parent, that means it's an is a relationship. I will repeat it again. It is an is a relationship. Is a relationship means whatever the properties is there between the child and the parent, that should be similar actually. That is an is a relationship because you can see here the parent has three properties: walking, eating, speaking. And so child also is having three properties: walking, eating, and speaking. But child can have its own implementation, because you can observe here the child is having its own implementation for all the three methods. But the principle is same. Like for example, the parent is walking in a different way. It has its own implementation. That means the parent is walking. Parent has some style actually of walking, some style of walking. It has a way of walking. Similarly, even the child has inherited the property walk, it has its own way of walking. So that's why it has its own implementation. And the same thing applies to the other properties as well, like eat property and the speak property. So this is an easier relationship. The properties between the child and the parent is similar. I can't say it is same, it is similar. So now let's consider. So down the line, the parent wants to learn singing because parent is interested in singing, so he wants to learn singing. So the parent has incorporated singing skills in him. But now, as per the inheritance concept, the child also should learn singing. But the catch here is the child don't wants to learn singing. Let's assume that the child don't want to learn singing. But because of the inheritance principle, parent has learned singing and has implemented it. So the child also should learn singing just because the parent has learned. Is it feasible or it advisable or is it correct? I can say. Let's consider the practical situation. Let's say we have a father and son actually. Father will be having some properties. Even the son is also having some properties. And father is having his own set of interest. Does it mean that son also should have those set of interests in him? It is not. But let's apply the same thing for inheritance also here. Just because the parent learned the singing, the child also should learn singing here. Whether the child can sing in the same way as parent, or child can sing in its own way, like overriding, I can say. But the child should learn the singing actually, because this is as per the inheritance principle. Now let's implement that singing in the child class. Okay. Now let's consider here. Now the child is interested in learning the dance. Okay. Now let's paste this. Okay. Child can dance. Okay. Because child is interested in dancing, so he learned the dance. So does it mean that parent also should learn dancing? Definitely no. But see here, child extends parent. It means the child is inheriting the parent. That's one thing. But it is also, we know that it is an easy a relationship. Is a relationship. Is a relationship means both classes should have the similar properties. That is called as an is a relationship actually. This is literally correct. But here the child learned the dance, but the parent need not be learned the dance. This is as per the inheritance principle. So, in one way, as per the inheritance principle, it's acceptable. But if you considering the terminology of an easy relationship and application of an easy relationship, it is not correct because the child has adopted the dancing skill, and is not going to adopt that particular skill. So, it is not exactly an easy relationship because the child has adopted the dance. The parent is not going to adopt that. It is not exactly an easy relationship. This is the problem with the inheritance because whatever the properties parent possesses, the child must possess that one. And even the child is free to add its own properties. The parent need not adopt that particular property. So it is not exactly an easy relationship in this case, even though it seems to be. Now let's consider the composition. Oh, the same thing which we have implemented via inheritance, we can also implement via composition also. How we can efficiently implement the same thing via composition. Now let's have a look. Let's comment this. Okay. Now we have implemented parent class in a different way. It is again have three different properties. Like now we have a different set of classes as well here. The walkable class is there, and inside that we have a walk method that can walk, something like that. Okay, and similarly we can have the classes eatable as well as the speakable classes. It is capable of eating and speaking respectively. So this means that parent as now let's have a look at these two classes as well for better understanding, eatable and speakable. Okay, Now let's come to this parent implementation. Now this means that the parent is composed of these three behaviors like walkable, eatable, and the speakable. It has three properties. In the same way, child is also composed of these three properties: walkable, eatable, and the speakable. Both, but one thing we have to observe here is we are not inheriting the parent class here. It independently acquired these three properties: walkable, eatable, and the speakable. Now let's say we have seen in the inheritance example that parent is interested in singing. So now let's say we can add it here. So now the parent has adopted the singing skill here because he's interested in it. But in inheritance, we have seen that the child also should adopt this skill because the parent has adopted it. But here in the case of composition, it is not the case because it is not an is a relationship. It is as a relationship. Let me repeat, as a relationship. Composition is a as a relationship. So what is it means as a relationship means? In the is a relationship means like child is a parent. That is an is a relationship. So because the properties between the child and parent are similar, it is called as an is a relationship. As a relationship means certain class as a certain properties. It is possessing certain properties actually. What as a relationship says is what a class is able to do or what a class can have. Importantly, it is an as a relationship. A parent can walk, parent can eat, parent can speak. Similarly, a parent can sing. That is what a parent is capable of. Similarly, here the child also. Child is not inheriting the parent here. It independently acquired these three properties. The child can walk, the child can eat, the child can speak. Independently acquired these properties. The child hasn't acquired these properties just because the parent has acquired. Because in inheritance, we have seen that just because parent has acquired some properties, child also adopted that properties, even if the child is not at all interested. But here in the composition, it is not the case. Because it is not an is a relationship, it is an as a relationship. Here in as a relationship, it independently acquired certain properties here like walking, eating, and speaking. Similarly, let's say in the inheritance also we have seen that the child wants to learn dancing. It simply add that. And we have this class as well, danceable. And we have a method called dance. So the child as the object of this danceable. Okay. Now because the child is interested in dancing doesn't mean that here the parent should also dance because these two are independent classes here and have composed their own set of behaviors here. Parent is composed of walking, eating, speaking, and uniquely composed of singing. In child, it is also composed of walking, eating, speaking, and it independently composed of dancing actually. There is no relationship between the parent and the child here. Because here the child is not inheriting the parent's properties, it independently acquires certain properties of its own interest. This is the composition mainly. Because in the inheritance, the problem is that tightly coupling. The problem with inheritance is coupling because whatever the properties the parent have, the child should also acquire that. It is a way of tightly coupling. So What happens is in our project or in our application, when we develop many number of classes, suppose if we use inheritance vastly without much need, what happens is, like, see, over a period of time, suppose if we have incorporated some property in a parent class, then we must incorporate the same property in the child as well, even if the child is not at all interested or needed that particular property. It is going to happen in the real-time projects as well. So that's why, because of this tight coupling between the classes, we must avoid inheritance as much as we can. So we have to go to the composition, and we know that both composition as well as inheritance serves the purpose of the code reusability. And one thing we have to remember here is, just because for the code reusability principle, we should not go for inheritance. We should use inheritance only in cases of the dynamic polymorphism. Whenever there is a case of dynamic polymorphism, then only we should go for the is a relationship or inheritance in a way. Otherwise, if we have no need of dynamic polymorphism, then we must stick to the composition, because we know the problems of the inheritance, which we have already discussed. So yeah, this is the that's why all the design pattern principles, there are many design patterns which is going to follow this principle. If any particular design pattern has an application of dynamic polymorphism, then in that particular design pattern we are using the inheritance or an is a relationship. Suppose if there is no such need of the dynamic polymorphism, then we always stick to the composition for any design pattern. So that's why the second principle for composition over inheritance is so much important, and it is very much needed in almost all of our applications in any of the design patterns. So this is all about the principle for composition over the inheritance. In our next session, we are going to discuss about types of design